Let's take a look at solving some trig equations with trig identities. Okay, so whenever that happens, whenever you need a trig identity, it's going to be that usually there's two types. Now, actually, in this first one, I'm going to show you a way that you actually don't have to use a trig identity, but I have another problem here that we will use one. So if you look at this, there are two trig functions here, right? We have sine and cotangent. And so when I see this right away, what I'm going to do is I'm going to say, okay, well, if there's sine and cotangent and I see cotangent in both terms, I'm going to go ahead and divide that out. So if I divide it out, I have 4 sine squared x minus 1, and that's equal to 0. Okay, so notice now I have my cotangent outside. I got 4 sine squared x minus 1, and that's equal to 0. Now, it's going to be tempting to just divide by cotangent and say, okay, now it's gone. But you have to be careful because if you do that, what you're really doing is you're getting rid of the solutions or solution where cotangent of x equals 0. Okay, so let's actually, we'll go ahead and write 4 sine squared x minus 1 over here equal to 0, and we're going to solve that as well. Remember, because the problem asks for it, we're looking for only solutions from negative 180 to positive 180 in degrees. So looking at where cotangent equals 0, well, remember that cotangent is just cosine over sine. So all you really have to worry about is where does cosine of x equal 0? Okay, so if you think about the graph of cosine, if you can envision that, you can see really quickly where it would equal 0. I'm just going to draw you a very small portion of it, but we know that the graph of cosine starts up at 1 here, and then it goes down to 0 at 90 degrees, right? It also, if we go in the opposite direction, goes down to 0 at negative 90 degrees. Now, if it was to continue, it would go over here to 270, but we're not looking for that number. We're only looking for the instances from negative 180 to 180. So my first two solutions that I'm going to record here is going to be that x equals 0 for a cotangent of x equals 0, basically, at 90 degrees and negative 90. So I got two solutions right there. We'll write them at the end when we get our other ones. Okay, so next we have 4 sine squared x minus 1 equals 0. Now you could do U-substitution, but I think this one's easy enough that I can say, okay, well, 4 sine squared x equals 1. So sine squared x equals 1 over 4. And then I need to take the square root of both sides. Remember, interesting thing that is very easy to forget, when we take the square root of a number, we got to say plus or minus. So what does that really mean? Well, that means we got two more solutions to consider. Well, sorry, two more equalities or trig ratios for sine that we have to find an answer for. So if I look at this, this is saying sine of x equals 1/2 and sine of x equals negative 1/2. So let's go to kind of thinking about the unit circle really quickly, and we can get our other solutions. Keeping in mind that we need to state them from negative 180 to 180. Okay, so if I think about where does sine of x equal positive 1/2, well, that's pretty easy. That's going to be where we have a 30-degree angle here, right? If this is 30 degrees, we have an opposite of 1 and we have an adjacent of 2. Same thing here, okay? So if I look at this with a reference angle here, really that's going to be 150. So we're going to have two solutions that are within my range of 30 degrees and 150 degrees. Next, we have where sine of x equals negative 1/2. Well, that is just a reflection of these other ones here. And so with a reference angle of 30 degrees, now you could say that's 330, but you could also think about the fact that if we go in the negative direction, that's just going to be negative 30. And that's the angle we want because we want from negative 180 to 180. So that's going to be negative 30 degrees. And then we got one more to worry about. Over here, we have our last triangle, and that is going to be, well, you could think of it again as 210, but if you go in the negative with a reference angle of 30, you're going to really have negative 150. Okay, so I got 4 solutions here, and then I have my first 2 solutions that I'm just going to rewrite from where cotangent of x equals 0. And so this one is pretty tricky. You end up with 9 total, or sorry, not 9. You end up with 6 total solutions, and that's from negative 180 to 180. Okay, let's look at one more here, and this one will be slightly different. We're going to have to use a trig identity in order to solve this. So we have another problem here, and now notice this says negative infinity to infinity, so that's really all real values of x is what that means. And it also means that we're going to have to change our notation, but we only need to find like however many solutions there are, and then from there we can write our notation to represent all real values, which is really those 2 angles, or however many they are. This one, hint, hint, has 2, or however many they are in all of their coterminal angles. Okay, so when I look at this one, right away I see, okay, I got cosecant and I got cotangent. So there is a Pythagorean identity that is going to come in handy here. And that is that 1 plus cotangent squared x, right? 1 plus cotangent squared x is equal to cosecant squared x. Okay, and now that, think about that comes from if I divide everything by sine, when I have sine squared plus cosine squared equals 1, you're going to get, once you divide everything by sine, you got sine over sine, cosine over sine, and then 1 over sine. So whenever I'm in doubt, I kind of think about those and I can derive it if need be. Okay, so we know that, right? So if we can get a 1 plus cotangent squared x, well then I can change it to cosecant x, cosecant squared x. But I don't really have that. So I'm going to start by moving everything over here and seeing what happens. Okay, so if I move this over, I got plus 3 plus 5 cosecant x. Because really what you're going to do is eventually solve a quadratic. So it helps if you have everything over on one side. Okay, so I got 2 cotangent squared x plus 5 cosecant x plus 4. Okay, now I'm looking at this and I'm saying, how can I create 1 plus cotangent squared x? Well, it's a little tricky, but if you notice, if I was to just split something up here, if I was, here, let's write it like this actually. If I was to take 2 of the 4 and just put it in front, and then I'll leave the other 2 over here. So I'm getting a little creative here. Now I could divide out 2, and I have this, what I'm looking for, right? I have 1 plus cotangent squared x plus 5 cosecant x plus 2 equals 0. Okay, so I had to get a little creative there, but sometimes you can just take, 2 plus 2 is 4, and so I just want to use 2 of those over here so that I can get a trig identity. So now I'm going to rewrite this with cosecant squared x, and now I'm down to one trig function that will allow me to solve this problem. So I'm going to go ahead and say, okay, well, that's 5 cosecant x plus 2, and let's let u equal cosecant x. So now I'm going to have a quadratic that I can solve. So I'm going to go ahead and write it over here because we're running out of room there. And that is going to tell me something that I got to factor. Okay? Now, if I look at this, I always do factoring by grouping just like this because to me it's the easiest way to kind of guess and check, and then you can get your answer. Well, I need to get 5 in the middle, right? So if I do plus 2 here and plus 1, there's only one way to multiply to 2 and 1. Well, that leaves me with 2 plus 2, which is 4, and that doesn't work. But if I put the 2 here and I put the 1 here, now I have 2 times 2 is 4 plus 1 is 5, and now I factored this correctly. So now I get to an answer. I get This one is going to give me u equals negative 1/2. And this one is going to give me u equals negative 2. All right, so now let's go back and say, okay, well, u equals cosecant of x, so cosecant x equals negative 1/2, or cosecant x equals negative 2. There's a problem with one of these, and that's that the graph of cosecant actually never goes through negative 1/2. It stops at negative 1 because it's opposing, or it's the reciprocal of sine of x, so it never goes through negative 1/2. So this solution is extraneous, don't have to worry about it. So all I'm worrying about really is where cosecant of x equals negative 1/2. And keep in mind that that's the same as where, since it's the reciprocal, where sine of x equals negative 1/2. Now we just did that where we had sine of x equal to negative 1/2, but if we want to go and find our two solutions, we can go set up our kind of a makeshift unit circle, and we're going to say, well, opposite over hypotenuse is going to give us here and red over here. Now, because you're looking for all real values, remember we're talking about negative infinity to infinity, it doesn't matter if I use a negative number or a positive number. Either way, I'm going to have my right answer. So for this time, we'll just use the positive numbers, but you could keep in mind, like, if we were to go 30 degrees more than 180, then we got one solution, which is 210, right? And then if we were to keep going, right, if we go all the way here to 360 minus 30, that would leave us with 330. Now, you could write that as negative 30 and negative 150. Either way, doesn't matter, but we do need to write it in a final notation that tells us all of the coterminal angles. So here's our final answer, 210 degrees plus 360 n, where n has to be an integer. And that's the way you want to notate that, so you show all of the answers. So that's for 210. And then we have 330 plus 360 n, where n is in the set of integers. Okay, so those two answers are our final answers, and now we're done with this one.